What does that mean? 19% is standard in the industry. If you go to Lowe's and Home Depot, the maximum moisture content they can sell you is 19%. So that's what we buy. Lumber with 19% moisture content. Okay, in that table, you can see species and grade. We've got 1, 2, 3, 4, 5 different types of wood. So you read the problem, figure out what you got. And then within the species, you've got grades. And most of them have 3 categories. The problem statement will tell you which one of those species and the grade within the species to use. Okay, if you look at it, the first column is extreme fiber bending. That's the little f in all those equations. So write that in there. We're not going to be using the next 2 columns. Compression perpendicular to grain and parallel to grain. H in all those columns is this one. And then the modulus of elasticity, E, is the last one. So you're going to need species and grade, bending, horizontal, modulus. This takes care of the bending, this takes care of the shear, this takes care of the deflection. Okay, if you go down below this hem fur, adjustment for moisture content. Okay, what happens? The wood gets wet, the allowable stress goes down. So they make adjustments there. If you look at it, you multiply the allowable stress by 0.86. If it happens to be bending, 0.97 for shear, 0.97 for modulus. So this is an area that students have a rough time with. Okay, I'm gonna give myself a little more room here. I'm gonna erase part of this since we've already talked about it. Okay, this will be used for, in your case, for boards. Why boards? How's it going to get wet? It's going to get wet if you pour concrete and the concrete lays on it and the material sucks up the moisture in the concrete. That means it's sheathing. So this has to be for sheathing. We only have 2 types of sheathing in this particular part of the course. One part is boards, the other part is plywood. Plywood is taken care of down here. And plywood already has moisture considerations taken care of. So this is already wet. Already. You don't have to put any factor on it. It's done. The moisture, and if you read it closely, you can see plywood sheathing used wet. Okay? So the only time you're going to use this is we've got sheathing and it's boards. Okay, the next one. Increase for low duration. 7 days or less permitted for lumber and plywood. So this is going to be all materials. All materials. And how do you know? If we're going to use it once and throw it away, we can use this duration increase. If we're going to leave it there for a long time or use it over and over again, we don't use it. So this is for one time in your world. One-time use. Okay? So if we use it once, what code allows us to do, it allows us to increase the stress. So when we get to problem examples, you're going to see what we do to do it. I'm going to change the numbers here. You can see it says for bending, add 25%. So we're going to multiply FB here, little f, times 1.25. Okay. Move on. It says horizontal increased by 1.25. So we're going to take H and multiply it by 1.25. And then it says do nothing for modulus. So when you look up your stresses allowable, if you're going to use it one time only, you're going to take those numbers and multiply this one by 1.25 and that one by 1.25. That increases it by 25%. So that gets us in a position where we've got data put together that we can fill all these blanks, except for W. Okay, W. W is a floating value. Figuring out the first one is the key. Once you have the first W figured out, then the subsequent W's are based on calculations using the first W. So, let me show you why you get to the W's. We've got two types of formwork. We've got one for slabs. So slabs. And this is W. And I'm going to call it W1. Why I'm calling it W1, it's the very first W we find. Now I said it's going to float. It's going to change from member to member to member. The W is going to change. So for sheathing, it's 1. For studs, it's another W. For whales, it's another W. So it's going to keep changing on us. So where do you find it? For slabs, it's chapter 5. And it's on page 5-1. Okay? So it's on 5, and if you've got the handout, the part that's shaded, it's on the right-hand column, just about at the very end. The paragraph it starts out with is ACI Committee 347 recommends vertical supports and horizontal framing components for formwork should be designed for a minimum live load of 50 pounds a square foot. So you're on page 5-1, chapter 5. It says live load 50 pounds a square foot. And it says that's if you've got workmen, runways, screeds, and other equipment. This happens to be without carts. If you read the next statement, the minimum should be with motorized carts. Use a minimum of 75 pounds a square foot. With carts. How are you going to figure it out? Read the problem. It'll tell you. Okay? So, now, in addition to that, we have the dead load of the material. So the dead load is going to be the weight of concrete. And that's T over 12 inches per foot times 150 pounds per cubic foot. So, per cubic foot. Now, they also have minimums. So, total load min without carts and total load min with carts. So if you read it and you follow it through a little bit, it says, if you'd have a thin slab, you got to use 100 at least. And if you got carts, you got to use 125. So our first entry into these equations, W, well, it's going to be W1, is going to be either 50 plus the weight of the concrete without carts, 75 plus the weight of the concrete with carts, and the values have to be at least 100 and 125. So that gets us slab W's. Okay, so we're going to move forward, and I'll show you how to do that when we do the example problems. So that gets you the data for W1 for slabs, with and without carts. Okay, now we've got W1 wall. Okay.